We have a word problem here that we're going to use an inequality to solve. First thing we need to do is, with our highlighter, identify important information. So the first thing that I think is important is the sum, meaning we're going to be adding, of two consecutive integers is at least negative 35. And it asks us what are the smallest values of consecutive integers that will make this true. So we know our inequality is going to have addition. And then it's talking about two consecutive integers. Remember, we talked about consecutive integers and what they are. Consecutive integers are numbers on a number line that are directly next to each other. So if I have negative 2, negative 1, 0, 1, 2, 3, and 4, consecutive numbers would be right next to each other. So we could say that negative 1 and negative 2 are consecutive, or negative 1 and 0. We could say 2 and 3, or 3 and 4, 1 and 2, or 0 and 1. Would 0 and 2 be consecutive? No, because there's a 1 in between them, so they're not consecutive. Consecutive means they're right next to each other on a number line, and they're separated by a value of 1. So the first number, when we talk about two consecutive numbers, the first number, we're going to call that n. The second number, if it's consecutive with n, that means that it's 1 more than n, so we'll call that n plus 1. Now, our situation is the sum of two consecutive integers, or n and n plus 1, is at least, so it's greater than or equal to, negative 35. So we've got an inequality set up, and we can simplify this. Combine like terms, that becomes 2n plus 1 is greater than or equal to negative 35. Subtract 1 on both sides. Those go away. 2n is greater than or equal to negative 36. Divide by 2, divide by 2. Now I'm not going to flip my sign because I'm dividing by a positive. So we're just left with n is greater than negative 18, greater than or equal to. So let's put this on a number line. Got a number line. I'm going to put negative 18, one less, and one more. Be careful with your number lines. Remember that negative numbers move in the opposite direction than our positive numbers. I forget that sometimes too. And since it's greater than or equal to, it's going to be a closed circle on negative 18, and it's greater than, so it's moving to the right. So any numbers, 18 and 7, negative 18, negative 17, negative 17, negative 16, any of these consecutive numbers would be at least negative 35. So the question asks, what are the smallest values of consecutive integers? Well, let's look at our solutions. Our solutions include 18, 17, negative 16, and so on. Which one of these is the smallest solution? The smallest value is negative 18. So negative 18 and the next smallest value, which is negative 17, will be our solutions. So negative 18 and negative 17. All right, so this example is talking about Joe. I'm going to get my highlighter and I'm going to highlight important information. Joe starts with $400 in a savings account at the start of the school year. He wants to have at least $275 in the account after winter break. He withdraws $25 each week for clothes and food. How many weeks can Joe withdraw money for him? Can Joe withdraw money from his account? So that should say from his account. Sorry about that. So we want him to have at least $275 in the account after withdrawing this. Now, some of us might be able to do this without even setting up an inequality, and that's okay, but there are going to be questions where they say, identify the inequality that matches this. What inequality can be used to set this up? So that's why we're practicing writing inequalities. So let's identify our variable. What is changing? What are we looking for? Well, we're looking for the number of weeks. So I'm going to say W equals weeks. And he's starting with an amount. He starts with $400 that he saved up. He's going to take money out every week, and he's going to take out $25 per week. All right, and we want him to have at least $275 in the account. So that means at least. So 275 is the minimum amount that could be in there. It's going to be either equal to that or greater than that. So we've got our inequality set up right there. So you might have a question that says which one of these inequalities would be used to solve this situation. That would be, excuse me, that inequality. All right, now we're going to solve. So eventually I'm going to get to this negative 25 weeks, but first I need to move over this 400 by creating a zero pair or subtracting 400. Right. We've got 0, and we're left with negative 25w is greater than or equal to 125. It's going to be a negative 125. All right, from here we're going to divide both sides by a negative 25. Alarms going off in my head. I'm dividing by a negative. What do I have to do? Got to flip that sign. So we're going to flip the sign. We're just left with w equals, or not equals, is less than or equal to 5. So I told you guys in class, if you have a situation, a problem that's got words in it like this, your answer needs to have words in it. Don't just write this as the answer. This is important and we need that. We can also write a number line with it to really get an idea of what it's saying. We've got 5, 4, 6, a closed circle on 5 going to the left. But what does it mean in terms of Joe's situation? Well, it means that Joe can withdraw money. He can withdraw money for 5 or less weeks. He can only withdraw money for 5 or less weeks. So he could withdraw money for 5 weeks, for 4 weeks, for 3, 2. He could withdraw money 0 weeks. He'd still have at least $275 in the account. But as soon as he withdraws money for a 6th week, he's not going to have enough money. That's why our graph shows 5, 4, 3, and so on. Anything less than 5 or equal to. Last question for tonight. So we're going to highlight the important information. The length L of a rectangle is 5 times the width W. The perimeter of the rectangle is at most 40 centimeters, so we're talking about the perimeter. Write an inequality that expresses all the possible lengths of the rectangle in centimeters, and then we're going to use that perimeter equation. So let's define some variables. Length is 5 times its width W. So they tell us length in terms of width. We also have the perimeter equation, P equals 2 times L plus 2 times width. Okay. So how are we going to use this? Well, we're going to take L and we're actually going to plug in 5W wherever we see L in our equation. So it's going to look like this. It'll look like 2 times 5W plus 2W, that's our perimeter. And we said that the perimeter needs to be at most 40 centimeters. So if it's at most 40, it could be less than 40, and it could also equal 40. So it's less than or equal to 40. So the inequality that we're looking at is this. At this point, we're going to drop the P for perimeter because we don't need that anymore. That was just in our formula. All right, now we can actually simplify. I've got 2 times 5W, which is 10W, plus 2W is less than or equal to 40. 10 plus 2 gives us 12W, which is less than or equal to 40. Divide both sides by 12. W is less than or equal to, we're going to get a decimal, that's okay, 3.3 repeating. So this is telling us that the width is less than or equal to 3.3 repeating centimeters. However, our question is asking us for the possible length of the rectangle. So if length, remember, is 5 times the width, let's plug that in. So length is going to be less than or equal to 5 times 3.3 repeating. So I've got 3.3 repeating in my calculator, multiplying that by 5, and we're going to get that the length is less than or equal to 16.6 repeating. So Again, this is a situation that started with words, so our answer needs to end in words. So the lengths is at most 16.6 repeating centimeters. And that's it.